problem number 1. For this first page, we did 3 problems on this one initial value problem, which is y of t is equal to y minus pi over 2 times sine y, and that is our y prime of t, where our y of 0 is equal to c. My first step initially was solving for what y of t is equal, and doing integration by parts. I come to the conclusion that our original y of t is equal to pi over 2 minus y times cosine y plus sine y plus c is equal to 0. And for our first problem, it says that if c is equal to 4, and as the limit of t is approaching negative infinity, y of t is equal to what certain value? And as I've written here, we have that as t is approaching negative infinity, we are approaching the value of pi, not pi, 2 pi. Right. And furthermore, we have a true-false. And the true-false for this is if c is equal to 2, and then y of t is between the range of 0 and pi for any t in the range of negative infinity to infinity. And from our true-false subjects, we show that it is true. The reason why is because our constant, which is 2, is sort of similar to the value of when it was equal to 4, when it was 2 pi. So seeing that c is half the value of what it was from problem number 1, we can be sure that the range is half of that, which is pi. So it ranges from 0 to pi. Okay. And then finally, heading on to the third part, it says, what is the equilibrium points of the given initial value problem and their stabilities? So right now, what our points that we're looking for is our equilibrium points. And that is when our function is equal to 0 or is undetermined. And initially, as we look at this, we show that when y is equal to pi over 2 and 0, they are showing that they are unstable, or are stability points, which we have to check. And the way we check that is to create a graph and set our points. And as we set our points, we have to test to see if it's going to negative infinity and positive infinity, because it cannot be defined in these areas. So initially, when testing them, we know that when y is equal to 0, that it is reaching our infinity. And then between the points of 0 and pi over 2, it shows that it's going from positive infinity to negative infinity. And finally, when the range of y is greater than pi over 2, showing that our y is approaching infinity from negative infinity.